Good morning, everybody. You're really the diehards of the conference, I think, to show up on Saturday morning here. Let me see how this works. Okay, and the light. Yep. Okay. Like Tobias said, I've been working with Ericsson for 15 years. And in the last 10 years or so, we've been actively hosting the digital library of beeld en geluid, of sound and vision. And in doing so, we've encountered a lot of problems in getting the content into the system and preserving them. So I thought it would be a great idea to actually share this experience with you and make the topic of the talk long-term preservation of a digital library, because I think you're all very concerned with long-term preservation in general. But actually, as I will show you, the quest doesn't stop once it's in the digital arena. Well, long-term, that's of course a subjective measure. What do you mean with long? And there are some slides that actually tell what do I mean with long. Is it 5 years, 10 years, 20 years, 100 years? So, the future of digital libraries. First of all, a little historical introduction about how do we get it here? How is it actually possible that we do the things with the digital media that we do today? And the big driver in the industry, and basically everything that you do at home and from a consumer perspective, came from commoditization of technology. But then, if you have all that content in your vault, where do you go from there? Because that's not where the story stops. So where do we get here? Everybody's probably familiar with Moore's Law. That is a guy from the 60s that predicted that the rate of technological development was exponential rather than linear or some other strange function. And actually, if you look at the sorry about that. Different button. Look at the graphs for all different kinds of technologies. There is actually an exponential development that can be indicated. And the slopes are not the same, meaning that the exponent itself is not fixed. It's not always 2 or a factor of 2 in 18 years. Sometimes it's a factor of 2 in 30 months or in 18 months or even 6 months. But actually the trend is that it is exponential. And that actually is a good thing, because that means that over time you will be able to store more data in the same volume for the same price. Or differently, you can store the same data in a smaller volume at a lower price. And this has been going on since the 60s, and it's really staggering if you look at the extrapolations, how accurate this prediction has been. And it's still going on. I mean, I can remember clearly from the early 90s that we thought, well, these transistors, they can't get any smaller, these memories, they can't get any bigger, and there will be a limit dictated by physics that it will flatten out somehow. And that was 1990. We're 25 years on, and it's still going strong. There's a lot of speculation, of course, about what the future will bring, and that's being indicated in this graph here. In 2010, a guy made a prediction that actually the development of hard disks and solid-state storage would flatten out, and tape would accelerate even. So the density of a tape would actually increase faster than it had done in the previous years. The opposite has turned to be the case. Hard disks and solid states have taken up, and actually tape is going slower than before. There are actually 3 things in technology that are important for this to make it possible. That's video processing capabilities. If that becomes a commodity, then you can do the things with the video that everybody wants to do. You need mass storage in the petabytes to become affordable. And you need asset management actually to manage all the stuff that you have in your archive. So commodity is a blessing, but it's also a curse, because commodity actually drives the financial models behind the technology. This is taken from Professor Richardson. It's a life cycle of a product. Everybody has seen this probably before. And the top curve is very known, that you develop a product, then you start harvesting, and then there's sort of a decline at the back end. But what's mostly not shown is actually this one. That's the industry profit from it. And that's where the culprit lies. Because once you are over the top with your technology, once it has become commodity, then the profit declines. But that also means that the research that goes into the development of the product declines, because research and development of the technology is, of course, driven by the profit that you can possibly gain from it. And then it really helps, or doesn't help actually, if you're in a niche market, like mass storage, storing petabytes, hundreds of petabytes of data, that actually it becomes difficult once the terabyte range has become a commodity, but it doesn't go much beyond that. There are, though, technology trends that actually promise that things will continue for some time to come. Tape is moving on. I mean, tape is, the density of a tape drive, actually the gigabytes that you can put in a cubic centimeter is still increasing, but it's not going as fast as we think, particularly in the LTO arena that most of you, I think, are using. The release of LTO7, for instance, is postponed, or at least not clear when it's going to be available. And LTO6 had some delays as well. And even that, not only the delay itself, but it's also the capacity that is finally then on the shelf is less than that was predicted some years ago. But then again, it goes. But there are other technologies on the horizon, say in 10 years or so, that could actually turn this picture around. The solid state is on the move. Hard disks are still getting bigger and bigger. And actually, if you look at building an archive from scratch now, and you have only, say, 1 petabyte of data to store, it is actually more cost-effective to buy hard disks at this moment. So, only if you are in the multi-dozen petabyte range, so to speak, say 10, 20, 30 petabytes or so, then tape actually makes sense still. But then, once you have all your data in your library, safe and sound, and it's all been arranged, then you think, well, you can lean back and enjoy the ride. Well, that's not true, because as you know, in the digital area, it is no different than the analog area. Once you have a tape written, the tape starts decaying from the moment that it's been written. And after 10 years, you start getting read errors. At first, they will be correctable because there's CRCs and extra data on the tape. But at some point in time, say 12, 15 years, depending on the conditions of the tape, you will start losing data. So you have to actively work with your media to keep it alive. But then again, there's another thing, that the actual files that you've written in your library, they won't last forever also. And then, of course, can you afford it? Because there's also the total cost of ownership of having this apparatus or this archive in the air with all the costs around it that you actually have to be able to afford. So let's deal with media formats first. So the question is simple. Will I be able to interpret and use the media in, say, 10, 20, 50, or maybe 100 years' time? Well, it depends, because in my opinion, future-proof media formats do not exist. If you look at the developments on the PC, for instance, you have a simple Word document from 1993, you cannot open it anymore. You have to actually cut and paste the text into something else that is more standard or more supported to keep this text moving through the ages, so to speak. International standards help, and of course also widely used formats help. And actually there are a couple of things that you can do to make this easier. Like I said, international standards like SMPTE and ISO they actually make sure that whatever you write on the tape is documented and it's open, that everybody has access to how the file was structured and how that actually the pictures and the sound and maybe even the text and other things can be extracted from it. Now, this sounds really good, but in effect it's only limited, because if you look at the complexity of an H.264 encoder, it is so complex that even if it is documented well, and you find the document, say, in 100 years, and there is no code around, it will take a really long time to reproduce the code that actually decodes the stuff. So I always say that H.264 is next to encryption. If you lose some of the data, then it becomes very difficult to get the picture out of it. And actually, if you go back to the simplest thing that you can store in data, that's raw data. It's baseband, audio, and video. Like here in this thing, that it is, for some formats, really trivial to encode this type of information on a disk. And actually, if you look at the format that's been stored right now, we are already doing this for audio. Audio is being stored widely in WAV or BWF formats, which is lossless. You write PCM samples out to tape. And it's a lot of bandwidth, of course, because, as you know, it can be compressed and much easier. But since it is not so much data, because it's audio, people are already doing this. And maybe in 10, 15 years' time, when storage has become so big and so cheap, we can do the same thing with video, and then actually this problem disappears altogether, because storing it in baseband will allow you to decode it at any time in the future, easily. And then how to get there? Most of you are using compressed formats at this point, MPEG-2, maybe H.264, AVCI, stuff like that. Once this format becomes obsolete, like MPEG-1, for instance, that's a good example, MPEG-1 from 1991, it's completely open. You can download the document from ISO. You can read bit for bit what it means. But having actually supported codecs from the industry at this point in time for MPEG-1 is already becoming a problem. So it doesn't help. So at some point in time in the future, you will have to start migrating your content to different formats. And really the holy grail is, of course, to do this losslessly. And going back to baseband is an option. But you could also change the wrapper but keep the codec the same, or do really intelligent stuff in the DCT domain. So my verdict here is, for the next 20 years, we'll be all right. After that, you can start having problems. And just keep a good tab on it and re-evaluate all the files in your archive for this particular problem. Then preserving the raw data itself. So the file, regardless of what kind of codec it is, what kind of a media format it is, will I be able to read the file in, say, 10, 20, 50, or 100 years' time? Probably not. And this is actually the bad news about the digital preservation. Because tapes and discs, as you know, they last 10 years. Also, discs last only 10 years if you put them on the shelf, you don't use them. If you use them, they last even, well, say, 3 years or so. But if you don't use them, if you spin them down and you keep them in the shelf at a good temperature, even then, the manufacturer doesn't guarantee the data to be intact over 10 years' time. But that's not all of the problem. The biggest problem is actually being able to read the media with a device which is compatible with the media in 10 years' time. I don't think that many people have a cassette recorder in their homes right now. I mean, that's an example from the analog era. I, for instance, don't have a CD-ROM player anymore in my home. I have really big chest with CDs, of course, that I can play with an audio CD player, but I can't read the CDs on my computer anymore, for instance. And basically, with every technology which goes through this product cycle that I showed, goes through this to the far end when it becomes obsolete and basically dies down. The other thing to know is that keeping these devices in stock, like CD-ROM players, for instance, it doesn't really help, because the interface that's attached to it, to actually connect to the computer and make use of it, that doesn't exist anymore. Because the computers also continually evolve. They only have USB connector, for instance, and you can't have an ATA board anymore in your computer. So the interfaces become obsolete, and also the software to actually read the media becomes obsolete. So there's the only thing that you can really do to prevent this is thou shalt migrate. So you have to keep your data live, and you have to basically put it through the motions and store it on a different media, on a different device or whatever. So you have to keep on moving and migrating your content. Continuous migration is what we call it. And in that sense, it's no different than in the analog era as well. The big advantage, though, is since it is digital, you can do it automatically most of the time. If you have a good medium with a tape robot, for instance, you don't have to have people actually touching the stuff. And since it is digital, and if you are in time, it is completely lossless in the sense that no information gets lost, provided, of course, that the media format is still valid. But suppose you didn't do all these things. You just start filling your archive, and you use the same media format, and you use the same tape format. You just start writing out tapes and tapes and tapes and tapes. And this is what happens. You have to keep expanding. The number of tapes go up almost linearly because, well, that's one of the assumptions of the model, of course, that your flow into the archive is more or less constant. That is basically for television archive anyway. the television programs that are being produced is also almost constant, so to speak. And so you have to continuously keep investing in new stuff. And actually, the library gets bigger and bigger. And you see with the stepping, every time you buy a tape library, and that's 8,500 in this case, you gain another 9,000 slots, and another 9,000 slots, etc. It is tempting to do this, because tapes, they last at least 10 years. And if you look at the time scale here, it is from 2007 till 2017. So, I mean, we're well within the 10-year range here, particularly the tapes that are created later on. Tapes don't consume any power, and basically if they're in the slot, they're safe. Nobody can touch it, and nobody can actually modify or delete or corrupt the data, so that sounds really good. And there are no migration risks, because you just don't migrate. Well, don't. This is not the way to go, because in the end, you will have an archive with 1, 2, 3, 4 tape libraries, and they will all cost money, and they will all cost maintenance, and after 10 years' time, you have a huge amount of tape that you have to migrate to a different format. And in that sense, it is the same as in the analog era, where there were shelves and shelves of real in the sense REEL, real tape video, that were just lying on the shelves and nobody could actually use anymore. So what do you do then? Well, you have to continuously migrate your content. And that's actually where I come back to the commodity aspect of it. Since the storage goes up exponentially and the inflow is only linearly, so theoretically the amount of space that you need to store it goes down exponentially, because you know exponential goes faster than linear, of course. That's actually exactly what you see here. I calculated this model over 4 generations of LTO. Started with LTO 4 here, LTO 5 here, LTO 6 here, and LTO 7 is predicted because that isn't ready yet. And actually, I have to admit that this graph was made in 2010 here, when even LTO 5 wasn't available yet. But what you can see is that the number of slots that you occupy in your library, that goes up, and you see here the point almost that you burst out of your first tape library, which was this one. And then we bought a new one. That was a big one, fortunately, so we could go on for a couple of years. And it goes on. And then if it went on, it would hit this point, and then we had to buy another one. So we said, no, that's not what we're going to do. We have to really start managing this amount of data in the tape library by migrating to a new tape format. And actually, it sounds a bit like a pity, because you're starting to copy tapes that are only 4 or 5 years old, and they last so much longer. But actually, going to a different tape library to buy more stuff is more expensive than actually sort of discarding the old formats and go to the new one. There's a business case for it. So what you really see on the envelope here is that first it goes up, because you have some catching up to do, and the tape formats aren't big, but then when LTO 5 and LTO 6 and LTO 7 comes out, you see that actually the number goes down again. So the number of slots goes down. So actually the tape library gets emptier and emptier. So finally, I would say that in 50 years, all the data in this tape library will fit on a data cube, no bigger than a sugar cube. Maybe that's true, I don't know, but at least the trend is there. And you can actually see that when I calculated this in 2010, this is exactly how it was done. And it was exactly when LTO 6 needed to come along and started to be used to get this number down. So this is exactly how the history unfolds. And that's also the good news, because these things you can plan way in advance. You don't have this immediate problem like, oh, I've got 30,000 tapes, and what do I need to do with it because tomorrow they decay? No, this is something that you can plan years in advance. Another thing is that, nice to know, is the bandwidth of this archive. The amount of content that goes in and out of the archive is actually peanuts here, because this is what goes in and out. But this is the bandwidth you have to use to migrate your content. So basically, after a couple of years, you're only migrating. And you take all the incoming stuff for granted. I mean, that's just peanuts compared to the rest. And the other thing that you can see is that you have to plan it carefully, because if you just wait too long, you just have to have some catching up to do here for some time, and then you can go back to the normal level. So normally, it should go basically in the same trend as the total volume of your archive. Then the financials, finally, cost aspects of this. Will I be able to afford the archive for the next 10 or 20, 50? Well, of course, nobody can look more than 10 years. like 7-year seal here. You can predict things, or you can make contracts or arrangements or agreements for the next 5 to 7 years easily, but not much beyond that. Depends a bit on how you actually do it. There are different models to do. You can buy, lease, or rent it, but you have to have your volume prognosis really in spec. Like I said, the technology development really helped because it gets cheaper. Maybe it goes in steps, but I mean, over 10 years, it really goes cheaper. And of course, the monetization aspect. Now, if you look at the cost elements that actually build this business model for owning and using this tape, there's a lot of stuff that you have to take into account. I won't go through all of this, but it's on the site. And all of this is potentially very expensive, so you have to be very careful how you do this. And if you plan it carefully with the data migration itself, you can actually get your cost to a very constant level. The spike here is with the procurement of the first tape library, you know, the big step of 8,000 slots or something like that. But then on, you can see that actually the cost goes down really gradually, and that goes down with the logarithmic, with an exponential increase of the storage capacity itself, approximately. Well, there's a constant factor in it anyway. Monetization is, well, that's how to get money back from it. Why do we do it? What's it worth? And how do you make money out of your archive? That's a topic that's been addressed on various talks already on this conference. It's very complex, actually. And it's really a matter of balancing the obligations that you have to do as an archive for the state, for instance. Merits in terms of reputation, for instance, a good one that I heard yesterday. And direct profit that you can get from actually exposing your archive to the public and make use of it in a commercial sense. One thing I want to pick out from this slide is this one. The quality of the metadata is really important. I mean, it's like Google. If people can't find it, it won't be used. It won't be shown. It won't be reused. And then it means that it's worth nothing. And if you realize that it only costs money because it's actually gigabytes sitting on a tape somewhere, and that costs money year on year, that's something really to think about. So what the future holds, this last slide, Tobias. Technology helps. It goes down. It may go in spurts. It may go gradually, but it will go down exponentially, fortunately, for some time. The stored volume will grow, but not exponentially, fortunately. In your cases, people predict that the amount of data stored all over the world is exponential, but that's because of the social media type of thing that you're not really into. Software is getting better all the time. But I predict a precarious situation between now and 15 years, and not only because there's a lot of stuff that needs to be digitized still, but also that storage is still a big cost factor, and the merits that you get from it aren't really clear. Assets run the risk of being wasted before it basically becomes trivial to store them indefinitely. And also the automatic processing by computer power and artificial intelligence is still, well, lacking behind, I would say. Picture and sound recognition for automatic annotations, basically that allows you to discover the media in a different way, that makes it more monetizable, is something that will need a lot of development in the coming 10 years, and I actually expect a lot of things to happen there. And the final thing is that cloud storage, some people have been talking about it. It is cheap to store. That's the basic picture. Everybody here is cheap to store. So why don't you do that? But you have to really read the fine print, that what it actually costs to get something back from it. For instance, if you use it as a DR copy, and actually the disaster happens, you will be bankrupt if you have to restore your entire archive from cloud storage. So that doesn't really help. So be careful about that. But it is an option, and actually the models around it are continuously evolving as well. So Amazon is thinking with you, so to speak. That's about it that I wanted to share with you. Are there any questions? I do bring a microphone. That might be threatening, but I don't bite. So.
It's not really a question, actually, because I arrived a little late, so apologies for that first. But it was just a very clear and very it's a very well laid out presentation to archive managers to help in the conversation with technology.
Yep.
You talked about the difficulties that there are for many of the parties still to invest even now. And it's taking a long time even to get those first early libraries. Some are light years ahead on that digital road, and others are still far behind. So I think the big challenge for you as the technologists and the industry, as I see it, is that you're often the front line of engagement with the companies, with the broadcasters. And it's often harder from inside to get the messages across about the archive. So I would just urge you to be advocates for the archive when you're in and out of our companies all the time, particularly around these areas, because planning budgets around migrating data that's healthy and well is not going to be easy.
That's right. And it's often forgotten.
If I went back and said, okay, look, we got to do this, I know, I'm sure you're right. But when you're struggling to survive as it is, it's going to be tough. So I think you have an advocacy role, so please do it. That's all.
Thank you.
Well, thank you very much, Henk. There'll be time for questions and discussions at the end.